Differentiation using the chain rule. We want to differentiate each function with respect to x. I'm going to use the outside-inside rule to differentiate y equals x cubed plus 3 to the power of 5. The outside-inside rule tells me that I need to differentiate the outside function, and then I'm going to differentiate the inside function and multiply them together. So to differentiate the outside function, I'm going to just treat this like it's just an x. I'm going to bring down the power in front, which is a 5, bring the 5 down in front, and reduce this power by 1, and I keep what's inside the bracket the same. So I bring down the power in front, reduce the power by 1. So I get 5 times x cubed plus 3 to the power of 4. So what I've done is I've differentiated the outside function. Now I need to differentiate what's inside my brackets, and the derivative of x cubed is going to be 2x squared. And I'm going to multiply this by what I differentiated as my outside function. So the derivative of x cubed is going to be 3x squared. Because what I did was I brought the power down in front, I brought the 3 down in front, and I reduced this power by 1. And I cannot differentiate 3, it's a constant, it does not have an x. So now what I have to do is multiply 5 by 3x squared to give me 15x squared, and then I just stick on my brackets. X cubed plus 3 to the power of 4. So the derivative of x cubed plus 3 to the power of 5 is going to be 15x squared times 3 times x to the power of 3 plus 3 to the power of 4. Next I want to differentiate minus 3x to the power of 5 plus 1 to the power of 3. So again I'm going to differentiate the outside function and then differentiate what's inside the brackets. So I'm going to bring down the power in front and reduce the power by 1. So the 3 comes down in front of the bracket and the 3 gets reduced by 1. So the 3 comes down in front. We still have minus 3x to the power of 5 plus 1 inside the brackets. 3 take away 1 is 2. Now I need to differentiate what is inside my brackets, and I'm going to multiply that. And the derivative of minus 3x to the power of 5 is going to be minus 15x to the power of 4. So the 5 comes down in front, minus 3 by 5 is minus 15, and 5 take away 1 is 4. I cannot differentiate plus 1, it's a constant. So now I just need to multiply the 3 by the minus 15x to the power of 4. So we end up with minus 45x to the power of 4 multiplied by minus 3x to the power of 5 plus 1 all raised to the power of 2. Next I want to differentiate minus 5x cubed minus 3 raised to the power of 3. So again I'm going to bring the power down in front, reduce the power by 1, so differentiating the outside function, and then I'm going to differentiate what's inside the brackets. So I brought the 3 down in front, kept everything inside the brackets the same, and reduced the 3 by 1, so I get 2. Now I'm going to multiply this by the derivative of what is inside the bracket. And the derivative of minus 5x cubed is going to be minus 15x squared. Because 3 by minus 5 is minus 15, and 3 take away 1 is 2. I can't differentiate minus 3, it's a constant. Now I just need to multiply the 3 by the minus 15x squared. So I get minus 45x squared multiplied by minus 5x to the power of 3 minus 3 squared. Next I want to differentiate 5x squared plus 3 raised to the power of 4. So again I'm going to bring the power down in front and reduce the power by 1. So the 4 comes down in front, everything in the bracket stays the same, and 4 take away 1 is 3. So now I'm going to multiply that by the derivative of what's inside my bracket. And the derivative of 5x squared is going to be 10x. As I bring down the 2 in front, 2 by 5 is 10. Reduce the power by 1. 10 take away 1 is 1. So 10x to the power of 1 is just 10x. And I cannot differentiate 3. Now I multiply the 4 by the 10x. So I get 40x multiplied by 5, x squared plus 3 raised to the power of 3. Now this next one is a little bit trickier, because first we have to rewrite this with a power. So the fourth root of minus 3x to the power of 4 minus 2 can be rewritten as minus 3x to the power of 4 minus 2 raised to the power of a quarter. So the fourth root of anything is really that raised to the power of a quarter. So now I can apply my chain rule. So f prime x, what I'm going to do is bring the power down in front, which in this case is a quarter, and keep my bracket the same, minus 3x to the power of 4 minus 2. And then I need to reduce my power by 1. And a quarter minus 1 is going to be minus 3/4. And that's going to be multiplied by the derivative of what's inside my bracket. And the derivative of minus 3x to the power of 4 is going to be minus 12x to the power of 3. And I cannot differentiate the minus 2 because there's no x. So now I need to multiply the quarter by minus 12x cubed. So my derivative is going to be a quarter of 12, which is going to be 3. So minus 3x cubed multiplied by minus 3x to the power of 4 minus 2 raised to the power of minus 3/4. Now I can further simplify this by changing it into a fraction. So the minus comes down in front. The 3x cubed is going to go into my numerator. And the minus 3x to the power of 4 minus 2 to the power of minus 3/4 goes into our denominator. And the minus 3/4 becomes positive 3/4. Now both answers mean the same thing, so either answer would do. Okay, so f of x equals the square root of minus 2x squared plus 1. The first thing we're going to do is rewrite this as a power. So we can rewrite the square root of anything as that to the power of a half. So now that we have a power inside our bracket, we're going to use our chain rule. We're going to bring the power down in front and reduce the power by 1. So f prime x is going to equal a half multiplied by minus 2 x squared plus 1 raised to the power of a half minus 1, which is going to be minus a half, multiplied by the derivative of what is inside the brackets. So minus 2x squared, bring the 2 down in front to get minus 4x to the power of 1, or just minus 4x. Now I just multiply a half by minus 4x. And a half of 4 is going to be 2, so minus 2x times minus 2x squared plus 1 to the power of minus a half. And I can further rewrite this as minus 2x is my numerator, minus 2x squared plus 1 to the power of positive half for my denominator. So either answer will do, they both mean the same thing.